Tick. But right now, if you want to upgrade your science, your maths and science marks, then we have got the perfect person in the studio. We've got Philip in the building, and he's going to be showing us using some very cool ways how you can upgrade your science. Philip, welcome back to the show.
Thanks, Sam.
It's always good to have you here. Okay, so you're going to upgrade our science. Let's get into it.
Cool. Well, what we're going to talk about today is units. So anyone who's doing maths or science out there, you guys are going to be using units.
Yes.
So Sam, what's the first thing that pops into your mind when I say maths and science units?
Units, it's like calculating a number of something.
All right, so give me an example.
Like millimeters, kilograms.
Ah, that's it. Millimeters, kilograms, exactly. So it normally comes after a number.
Yes.
It's more slim, yeah?
It's biaslim.
Biaslim.
Well, never mind.
Okay.
I was about to,
We'll get back to that.
Yes.
So the units normally come after a number, yeah? So, for example, 5 kilograms, the kilograms tells us how much stuff there is, yeah? But 5 seconds is telling us how long something is going on for. 5 newtons is how much force is being exerted, etc.
Okay.
But we're going to look at a very particular set of units today. We're going to look at a set which use ratios.
All right.
Another way of saying that is we're going to look at units that use the word per.
Yes.
Can you think of any units that use the word per?
We've got chickens per coop.
Chickens, that's not the first one that would have come to my mind.
If you're a farmer, or people per square kilometer.
Cool, yeah. We've got, what about meters per second?
Yes, meters per second or kilometers per hour.
Kilometers per hour, that's the speed, all right. So the thing about these units that use ratios, we're actually we're comparing two different things. So, for example, meters per second, we're looking at meters, which is your distance, and then you've got seconds, which is your time.
Yes.
Okay, so let's have a look on the board here. If I write 5 meters per second, all right, like that, and I know in your textbook, you're going to find it written like that, or these days, I think they actually write it more like this, right? 5 meters per second. I'm going to show you one more way of writing it, which I find very helpful. I write it as 5 meters in a ratio format.
Yes.
5 meters is to 1 second.
Yes.
So Samora,
I think it's very easy to understand when you look at it.
There you can see the relationship between your two units, the meters on the left-hand side, the seconds on the right-hand side. And if I say to you, Sam, if you're traveling at 5 meters per second, how far will you travel in 3 seconds?
You'll travel 15 meters.
You have hit the shoe here. Right, there we go. We have 3 seconds. So in ratios, what we do to the right-hand side, we do to the left. So we multiply by 3 there. So we're going to multiply by 3 here. And we get 15 meters in 3 seconds.
Yes.
All right, let's move on to our next demonstration. What we're going to do, instead of looking at meters, now we're going to look at population density.
Okay.
All right.
I did population density. I think I did that in geography.
So what are the units of population density? Do you remember?
People per square kilometer.
That's it.
Yes.
All right. And in Cape Town, we've got about 1,000 people per square kilometer.
Okay.
In New York, on Manhattan, there are 20,000 people per square kilometer.
Jeez.
Okay. So we're not going to look at square kilometers because that's a very, very big area.
Yeah,
so for our demonstration,
have a square kilometer in the building.
Exactly. We're going to look for a square meter. So what we're going to do is, can you help me construct a square meter?
I can do that.
There's your square. There's your meter rule. This is my meter rule. So if you put 1 meter down there, so that's 1 meter. Now we're going to make a square meter. All right. So it's 1 meter by 1 meter.
Yes.
So there's 1 square meter over there, and you can see we've already taped in another square meter there and another square meter there. All right, so now we're going to get some volunteers, some very willing volunteers. And we're going to ask Sam,
could a lady and a gent please come up and volunteer?
Great. Can you create a population density, just hang on a second there, of 2 people per square meter? 2 people per square meter. There we go. All right, so you can see what we've done here. It's 2 people in every square meter. Our population density here is 2 people per square meter. What happens if we wanted 3 people per square meter? We need a couple more volunteers.
We're going to steal warriors from King's Landing, and we're
getting cozy here. Sisi Polele with my Makaza gents.
Yes.
All right. So now
Me
we've got 3 people per square meter. All right. Thank you very much, Makaza gents. We'll see you a bit later. We're going to put this up on the board. So we were looking at 3 people per square meter. Now, in terms of the ratio format, we can write it as 3 people on the left-hand side is to 1 square meter. All right? So very nicely, we can see the ratio there.
Yes.
So how many square meters did we have here, Sam?
We had 3.
We had 3 square meters.
Yes.
And do you remember how many people we had in total?
Well, if we had 3 people in the 1 and we times it by 3, we'll get 9 people.
That's it. We had 9 people altogether. If you guys had counted, you would have seen there were 9 people in 3 square meters because we had 3 people per square meter. That's 3 people in 1 square meter. Right, last demonstration.
So now hashtag upgrades.
Very
Going
quickly.
1 more level, yes.
We're going for density, Sam.
Yes.
What are the units of density?
Cubic centimeters, cubic.
Oh, this
meters,
man is on
cubic.
form. Yes.
My dad would be so proud of me today, guys. Like, these are things I never got in high school, but I'm getting them today.
I promise you are getting it. So what we've got is a cubic meter. This is something which we don't get to see. So I've made one for us here. You can see here, it's about a meter by a meter by a meter. So there's a cubic meter. So do you know what the density of water is?
I have no idea, no.
It's 1,000 kilograms per cubic meter.
1,000 kilograms per cubic meter.
Which means that if we filled up this box, okay, it would leak a bit, so we'd have to have a plastic box. But if we filled it up with a whole lot of water, how much would it weigh?
1,000 kilograms.
1,000 kilograms, exactly, because it's 1,000
kilograms. Isn't that like
kilograms.
the weight of like some cars?
It's about the weight of a baby elephant.
Wow.
Yeah. Do you know what the density of gold is, Sam?
No idea.
The density of gold is about 20,000 kilograms per meter cube. So if we were to fill this up with gold, so just think about that for a moment, yeah? Fill it up with gold, then
This is
yes,
very
rich then, yeah. Then we would have 20,000 kilograms of gold here. Right. So let's just write that up very quickly in the ratio format. So for water, we had 1,000 kilograms per 1 meter cubed, right? There's our 1 meter cubed. So if I said to you, Sam, I've got 3,000 kilograms of water, how many boxes would that mass of water fill?
3.
Perfect. It would fill 3 cubic meters,
yes.
right? Which is 3 of these boxes.
Awesome stuff. Well, Philip.
And to finish, we've just got a challenge question for our viewers at home.
Yes, the challenge question. Let's go.
All right, so we've done meters per second, right? But what happens if I said to you, Sam, what is 2 seconds per meter? What does that mean?
So you guys head on over to social media. What is 2 seconds per meter? We already know what 2 meters per second would be. So we need to know what would be 2 seconds per meter. But right now, let's go for a quick commercial break. This is Hectic 99. See you after this.